Hello and welcome to my EDEXCEL GCSE Maths Higher Paper 3 predicted paper for this summer. Before we begin, some general information. Firstly, I'd highly recommend that you download and try doing this paper before watching the walkthrough. I've put a link in the description so you can download it to try first. The paper perfectly covers the advanced topic list material released by AQA in February 2022. All of the questions are original and created by myself, so you won't find these questions in any other paper. And finally, there's no guarantee that questions will be asked exactly in this way, but this is excellent practice for your summer exams. For this question, we need to draw a frequency polygon. To do this, we need to know the midpoint of each of the groups. So the first group goes from 10 to 20 minutes, so the midpoint of that one is 15. The next group's midpoint is 25, then 35, 45, and 55. We now plot these midpoints with the frequencies. So we're going to plot 15 minutes with a frequency of 7. That goes here. 25 minutes with a frequency of 20. 35 and 41. 45 with 19. And finally 55 with 13. Once you've done this, you join up all of your points with straight lines to complete your frequency polygon. For this question, we need to find the value of v. We're given a formula v equals u plus at, so we're going to write this out again, but substitute in the values. So v equals u, which we're told is 7, plus a, which we're told is 9.8, times t, which we're told is 15. If you type this into your calculator, you'll get the answer 154. For the next part, we need to make t the subject, so we'll write the formula out. First of all, take away u from both sides. On the left-hand side, this would be v take away u, and on the right-hand side, the u's would cancel, so you're just left with at. Then divide both sides by a, so on the left you've got v take away u, and then you divide that by a, and on the right the a's cancel, so you're just left with t. T is now the subject because it's on its own, so t equals v minus u over a. In this question, Martin eats 60% of a chocolate bar, and that chocolate bar has a mass of 350 grams. So if we do 350 times 0.6, we get 210 grams, which represents the amount that Martin actually ate. We need to find out how many grams of sugar Martin ate though. If you look at the information we're given, you can see there are 56 grams of sugar per 100 grams. This means that 56% of the bar is sugar. So if Martin ate 210 grams, 56% of this would be sugar. So we'll do 210 times 0.56, which gets you 117.6 grams. In this question, we're told that 35% of the counters are green. So if we do 800 times 0.35, we find out that there are 280 green counters. We're also told there are 26 blue counters and 800 counters in the bag in total. So if we do the 800 total counters, take away the 280 green counters, and take away the 26 blue counters, we find out there are 494 red counters. We're told in the question the ratio of red counters to blue counters is k to 1. So the red counters, there are 494 of those, and the blue counters, there are 26 of those. We need to write this in the form k to 1. To get from 26 to 1, you divide by 26, so do 494 divided by 26, and you'll find that k is 19. So the answer is 19. In this question, we're looking at the population in 2009 and 2019. We know the population in 2019, that's 576,000, but we need to work out the population back in 2009. Imagine the population in 2009 represents 100%. It says in the question to get from 2009 to 2019, we add 20%. So the amount in 2019 would represent 120%. If 576,000 is the same as 120%, we can divide both sides of this by 120, that would give 4,800 equals 1%, and then times both sides by 100, which would give 480,000 equals 100%. Since the amount we were after was equal to 100%, we found it. The answer is 480,000. For this question, we need to work out average speed, so we'll use the formula speed equals distance divided by time. The distance is 180 miles, we're told that in the question. The time is a little bit harder though. We can see that Keane leaves at 9:30 and arrives at 12:42. The difference between these gives us the time, which is 3 hours and 12 minutes. But we can't use 3 hours and 12 minutes in our calculation. The answer needs to be in miles per hour, so we need to write this time in hours. There are 60 minutes in 1 hour, so 12 minutes represents 12 out of 60 minutes. If you type this into your calculator, you'll get 0.2. So 12 minutes represent 0.2 of 1 hour, so we can rewrite this as 3.2 hours. We can now do the calculation, so it's distance divided by time. The distance is 180, divide by the time 3.2, and this will give you a speed of 56.25 miles per hour. For this question, we want to calculate the percentage decrease in temperature from Wednesday to Thursday. The temperature on Wednesday was 26, and the temperature on Thursday was 20. We'll use the formula, change divided by original times 100. So the change is 26 take away 20. The original amount is Wednesday's temperature, which was 26, and then we times by 100. 26 take away 20 is just 6, so we have 6 over 26 times 100. The question asks us to write the answer to 1 decimal place, so if you type this into your calculator and round it, you'll get 23.1%. We're going to find the area of a trapezium, so we'll need the formula area equals 1/2 a plus bh. A and b represent the parallel sides, so we can see those, they're 20 and 25. So we can write the formula again, area equals 1/2 20 plus 25 times the height. If we draw on the height, and then move this line across, we can create a right-angled triangle. If you now look at the bottom line CD, which is 25, and the top line AB, which is 20, the difference between these two lines must represent the base of the triangle. This means the base of the triangle is 5 centimeters, since 25 take away 20 is 5. We now have a right-angled triangle where we know 2 of the sides. We can find the missing side using Pythagoras. So if we label the triangle like this, A, B, and the hypotenuse C, we can then do a squared plus 5 squared is 13 squared, which gives a squared is 13 squared minus 5 squared, which gives a squared is equal to 169 minus 25. So a squared equals 144, and then a is the square root of 144, which gives you 12. So the height of this trapezium is 12. We can now substitute this into our formula, and if you type all of this into your calculator, you'll get 270 centimeters squared. We're told that Abu's code is a 4-digit number, so we're going to write 4 boxes, 1 for each of the digits. The number is even. This means the final digit must be a 0, a 2, a 4, a 6, or an 8. The first digit is a number 7, so we can write that in. The second digit is a multiple of 3. This means it can only be 3, 6, or 9. The third digit is a prime number, which means it must be 2, 3, 5, or 7. So altogether we have 1 possibility for the first digit, times 3 possibilities for the next one, times 4 possibilities for the third digit, and times 5 possibilities for the last digit. If you times all of this together, you'll get a total of 60 possible codes. In the question, we're told the vector 2a minus 3b. We can also work this out using the vectors we're given, so 2 lots of the vector a minus 3 lots of the vector b. To times this vector by 2, we just times 2 on the top and 2 on the bottom. So 2 lots of x plus 4 gives you 2x plus 8, and 2 lots of 8 gives you 16. Then we have minus, and 3 lots of the next vector, so 3 5s are 15, and 3 times y is 3y. We can now simplify this. Along the top, we have 2x plus 8 take 15. If you do 8 take 15, you get negative 7, so the top would be 2x take 7. And on the bottom, you just have 16 take away 3y. We now have a vector which represents 2a minus 3b, but we were also told in the question that 2a minus 3b is equal to 1125. If we equate the tops of these, we have 2x minus 7, and on the other one, 11. And if we equate the bottoms, we have 16 minus 3y, which must equal 25. So we have 2 equations to solve. For the left equation, add 7 to both sides and you'll get 2x equals 18, and then divide by 2 and you'll get x equals 9. For the right equation, add 3y to both sides. On the left you'll get 16, and on the right it will be 25 plus 3y. Then take 25 from both sides, 16 take 25 is -9, and the 25's cancel on the right, so you're left with 3y. Divide both sides by 3, and you'll get -3 equals y. So x is 9, and y is -3. For this question, we need to work out the gradient. To do this, we draw a gradient triangle. We then need to work out the change in the y values. They go from 80 to 20, so 80 take away 20 gives you 60. We then do the change in the x values. This goes from 0 to 8, so 8 take away 0 is just 8. To find the gradient, we do the change in y divided by the change in x, so 60 over 8, which gives you 7.5. For part B, we need to work out what the gradient represents. Since the y-axis is temperature and the x-axis is time, the gradient is representing the change in temperature with respect to time, or perhaps more accurately, it's the temperature increase per minute. For part C, we need to understand what the intercept represents. So it intercepts the axis at 20 degrees. Here the time is 0, so this would be the initial temperature. We can begin this question by writing on the information we're given. So AC is 42, BC is 30, and AE is 35. We can also work out AB by doing 42 take away 30, which gives you 12. The side we're trying to find is BD. Since we have similar triangles here, it might be easier to view these as a small triangle and a large triangle. For our small triangle, we have 30 centimeters on the left, and BD is the base. For the large triangle, it's 42 on the left, and 35 on the base. We can now write BD, divide by the corresponding side on the other triangle, 35, is equal to 30, divide by the corresponding side on the other triangle, 42. If you times both sides of this by 35, you'll get BD equals 30 times 35, divided by 42, which if you type into your calculator, gets you BD as 25. We're now given some extra information. We're told CD is 14, so we can add that to the diagram as well. We need to work out the length of DE, so we'll label that. Again, we'll draw two triangles. For the small one, we have 30 on the left and 14 on the right, and for the larger one, it's 42 on the left, and the right is 14 plus DE, since we need to add CD and DE together. We can now write DE plus 14 over its corresponding side, 14, is equal to 42 over its corresponding side, 30. If you times both sides of this by 14, on the left we get DE plus 14, and on the right, 42 times 14 divided by 30. If you type the right into your calculator, you'll get 19.6, and then take away 14, you'll get the answer 5.6. In this question, we're told p equals 12.4 to 1 decimal place. This means the lower bound would be 12.35, and the upper bound would be 12.45. We now need to calculate m using the formula we're given, but we'll do it once with the lower bound and once with the upper bound. So m equals 20,000 divided by p squared, and we'll start with the lower bound, so we'll do 12.35 squared, and that gives this number. We'll repeat this calculation using the upper bound, so m equals 20,000 divided by 12.45 squared, and that gives this number. We now need to work out a value of m to a suitable degree of accuracy. Looking at both of these numbers, the answer would be 130, and the reason for this is both the upper and lower bound round to 130 if rounded to two significant figures. To draw a histogram, you first of all need a frequency density column. To work out frequency density, you do frequency divided by class width. So we'll go through each of the classes. The first one goes from 0 to 5, that's a class width of 5. The next one goes from 5 to 15, so that's a class width of 10. Then 15 to 25 is also a class width of 10. And the final group, 25 to 50, is a class width of 25. If you do 18 divided by 5, you get 3.6. 28 divided by 10 is 2.8. 9 divided by 10 is 0.9. And 5 divided 25 is 0.2. Now that we have this information, we can label our axes. Starting with the frequency density axis, we need to go up to 3.6, so this looks like a suitable scale. The x-axis will be for the mass. We need to go from 0 to 50. And now we can draw the histogram. So the first group goes from 0 to 5 kilograms and has a frequency density of 3.6. The next group from 5 to 15 has frequency density 2.8. The next one goes from 15 to 25 with frequency density 0.9, and the final group from 25 to 50 with frequency density 0.2. For part B, we need to find dogs that have a mass between 10 and 25 kilograms. To do this, we're going to draw a vertical line onto the histogram at 10 kilograms and 25 kilograms. So we need to find the frequency between these 2 points. The bar on the histogram between 5 and 15 kilograms has a frequency of 28. You can tell that from the table in the question. Since we've drawn this line at 10, we only want half of this bar, so half of 28 is 14. The next bar that goes from 15 to 25 has a frequency of 9, we're told that in the question. So if we do 14 add 9, we get 23 dogs, but the question said what fraction of dogs. We're told there were 60 dogs in the question, so it's 23 over 60. In this question we need to find angle BGD. That's the angle I've drawn here. In order to do this, we're going to look at the triangle on the base of the cuboid first, triangle DHG. We know that side DH is 3 cm and side GH is 14 cm, so we can use Pythagoras to find side DG. So 14 squared add 3 squared is DG squared. If you do 14 squared add 3 squared, you get 205, and then square root this, you'll get DG. So DG comes out at 14.3 and so on. So we can label that onto our diagram, and if we now look at the red triangle, BGD, we know side BD is 3 cm, and we just found out GD, that was 14.3 and so on. The angle we're going to find is BGD, so we'll label that X. Since we have a right angled triangle, we can use trigonometry. We'll label the 3 as O, and the 14.3 as A. If we look at SOHCAHTOA, the one with O and A is tan. So tan of X equals the opposite, which is 3, divided by the adjacent, which is 14.3 and so on. To find X then, you just do inverse tan of this, so inverse tan of 3 over 14.3, and if you type this into your calculator and round to 3 significant figures, you'll get 11.8. Take care on this question to make sure you use the full number for the 14.3. Don't round it off here. If you're unsure, you could use the square root 205 instead of the 14.3. In this question, we have 5 girls and 3 boys, and we're selecting a team of 2 of the students, and we want to work out the probability it's 1 girl and 1 boy. So we'll first of all work out the probability that the first person's a girl and the second person's a boy. The probability of getting a girl is 5 over 8, since there are 8 students. And then we multiply this by the probability of selecting a boy, which is 3 for boys, but it's divided by 7 this time because you've already selected one of the girls. If you multiply these, 5 times 3 is 15, and 8 times 7 is 56. We'll then look at the probability of selecting a boy first, and then a girl second. The probability of a boy is 3 over 8, and then we multiply this by the probability of a girl, which is 5, and again it's over 7 since we've already selected one of the boys. This also gives you 15 over 56. We now need to add these two probabilities together, so 15 over 56, add another 15 over 56, which gets you 30 over 56. This is acceptable as an answer, although you may have simplified it to 15 over 28. In this question, we're told that there were 2 million bacteria in a sample when the chemical was added at 10:30 am. So at 10:30 am, we could say that the initial value, B0, was 2 million. 1 minute later, at 10:31 am, we'll need to use the formula given in the question, Bn plus 1 equals k times Bn. So to get B1, we need to do k, which is some number we don't know, times the previous value, B0. But we do know B0 is 2 million. If we now move on to 10:32 am, then B2 equals k times the previous value, which was B1. But we know B1, it's k times 2 million, so we'll substitute B1 for k times 2 million. If we simplify this a little bit, k times k is k squared, so we've got 2 million k squared. Now we actually do know the value of B2, we're given this in the question as well. When it says at 10:32 am the number of bacteria in the sample was 1,548,800, so we can substitute that number for B2. We now have an equation to solve. If you divide both sides by 2 million, you'll get k squared equals this number over 2 million. If you use your calculator, this comes out as 0.7744, and then if you square root both sides, you'll get k equals 0.88. We'll now move on to 10:33 am. So this is the value b3, which is equal to k times b2. But we actually know k now, it's 0.88, and we know b2 as well. That's the previous value, 1,548,800. So if you type this into your calculator, you'll get the answer we need, which is 1,362,944. For this question, we need to try and rewrite each of the parts as a power of 5. You should recognise 125 as being 5 cubed. So 125 cubed is the same as 5 cubed, cubed. 25 is the same as 5 squared, so we've got 5 squared to the power x plus 1, and the 5 to the 20 is already a power of 5. We can now use the bracket to a power law, which says when we raise a bracket to a power, we're going to multiply the powers. So 3 times 3 is 9, so the first part is 5 to the 9. For the next part, we need to multiply 2 and x plus 1, which gives you 2x plus 2. So it's 5 to the power 2x plus 2, and then we've got 5 to the 20. We're now multiplying some numbers with the same base, which means we add the powers. So 9 plus 2x plus 2 must equal 20. We now have an equation to solve. On the left-hand side, you can collect the 9 and the 2, so we have 2x plus 11, which equals 20. Take away 11 from both sides and you get 2x equals 9, and then divide both sides by 2 and you'll get x equals 4.5. For this question, we're trying to find the angle CAB, which is this one marked here. In the question, they tell us the angle ODB, which is 18 degrees, marked here. We also know that line OB is a radius and DBE is a tangent. A radius meets a tangent at 90 degrees, so this triangle is a right-angled triangle. Since the angles in a triangle add up to 180 degrees, we can do 180, take away 90, take away 18, which gives 72. So the angle BOC here is 72 degrees. You should know a circle theorem which tells you the angle at the centre will be twice the angle at the circumference. So we take this 72 and divide it by 2, and we get the answer 36, which is the answer to the question. For part B, we're told some extra information. We're told DE is 36 centimeters, and also the ratio DB to BE is 5 to 4. So let's write that ratio down. Now notice the line DE is the whole length of the line. So if we add the parts together, 5 add 4 gets you 9 parts, and we're told that DE is 36 centimeters, we just need to times by 4. So 5 times 4 is 20, and 4 times 4 is 16. This means DB is 20, and BE is 16. Now let's look at the right-angled triangle in more detail. So we know the base now is 20 centimeters, and we knew this angle here was 18 degrees. It would be useful if we can find the height here OB, which we'll label x. We can do this using trigonometry, so if we label x as O and 20 as A, if we look at SOHCAHTOA, the one with O and A is tan. So tan of 18 equals the opposite, which is x, divided by the adjacent, which is 20, and then if we multiply both sides by 20, we get x equals 20 tan 18, which on your calculator comes out at 6.498 and so on. We can add this to our triangle now, and also to our diagram. OB here is 6.498. Notice that OB is the radius of the circle. This means that OC, which is also the radius of the circle, must be the same length. The question had asked us to find the length of line CD. Now that we know OC, all we need to do is find OD, and we can find out this line. Let's add OD to our triangle by labelling it H. We can find H using SOHCAHTOA again by using cos. So if we write out cos of 18 equals the adjacent, which is 20, divided by H. If you rearrange this, then H equals 20 divided by cos 18, which if you type into your calculator will give you H equals 21.029 and so on. Now that we know OD is 21.029, and the radius OC is 6.498, if we subtract them, we'll get the line CD. When you subtract these values, you must make sure you use the exact values, not any rounded numbers. The question asks us to round our answer to 3 significant figures, so when you do subtract them and then round, you'll get the answer 14.5. It's worth noting there was another way to get the hypotenuse in this question. You could have used Pythagoras as well, since we knew DB was 20 and OB was 6.498. Either way, it doesn't matter as long as you get the right answer at the end. The first thing to do in this question is rewrite 5x to the negative 2 as 5 over x squared, using a negative index rule. For the fraction, we can factorise the top. x squared minus 9 is the difference of two squares, so you should factorise this as x plus 3 and x minus 3. On the bottom we have a quadratic. This one factorises to x plus 4, x minus 3. For the next fraction we'll leave the top alone as x plus 4, but on the bottom factorise out 2x squared, so you'll get 2x squared brackets x plus 3. There's now lots of cancelling to do. The x minus 3 brackets can cancel, the x plus 4s can cancel, and also the x plus 3s. So all we're left with is 5 over x squared plus 1 over 2x squared. If we want to add these together, we need to make sure they have the same denominator, so we'll times the left fraction by 2 over 2. Timesing by 2 on the top gives you 10, and 2 on the bottom gives you 2x squared. We can now add them together, so 10 add 1 is 11, so you get 11 over 2x squared, which matches the form we're asked to in the question. Because both of these simultaneous equations are written in the form y equals, we can set them equal to each other. So we can write 2x squared plus 30x plus 61 equals 1 minus 4x. We now want to get all of the terms on the left hand side. So first of all add 4x to both sides. On the left the 30x will become 34x, and on the right we'll just be left with 1. And then take away 1 from both sides. On the left we'll now have 60, and then 0 on the right. You can divide through by 2 on both sides here since 2 is a common factor, so you'll get x squared plus 17x plus 30, and of course 0 divided by 2 is just 0. You now have a quadratic that's quite easy to factorise. It's x plus 15 and x plus 2. This gives you two solutions for x, which is x equals negative 15 and x equals negative 2. You now need to get the corresponding y values by substituting these x values back into one of the equations. I think the bottom one's probably easier, so y equals 1 minus 4x, y equals 1 minus 4 lots of negative 15, which gives you 61, and also y equals 1 minus 4 lots of negative 2, which gives you 9. So our solutions are x equals negative 15 with y equals 61, and also x equals negative 2 with y equals 9. Thank you for watching this video, I hope you found it useful. I've put some rough grade boundaries here to let you know how well you've done, but of course we won't know the real grade boundaries until after the exams are done. Check out what I think you should watch next, and also subscribe so you don't miss out on future videos.